So, today's lesson is talking about graphing these rational expressions, okay? So, everything that we've done up to this point is going to help us in the sense of graphing these, okay? The main thing, just like before, is factoring. We've got to be able to factor these expressions, okay? Because that's going to help us figure out where points are undefined, where they're holes, where they're asymptotes, how we're actually going to graph this particular curve. Okay?
Excuse me, teachers, at this time, would you please release those?
So, a couple of things here. You need to look for these three items. You need to look for holes. Holes are canceled factors that when you set them equal to 0 and solve, there's a hole there. Okay? So whenever you factor, if there are factors that cancel out, there's a hole that lies when that factor equals 0. Okay? A hole, like literally there's an open space on the curve. Alright? Vertical asymptotes, abbreviated with a VA, are factors of the denominator set equal to 0. This is after you've canceled out. Okay? Vertical asymptotes, we talked about asymptotes before. What are they? A line that what? Can cross or touch. Okay? So, these are your factors in your denominator when you set equal to 0 and solve. After you canceled out those remaining denominators. Okay? Now, horizontal asymptote, this is a new one. We haven't talked about this before. But there are 3 different scenarios for horizontal asymptote. The first, you'll have a horizontal asymptote of y equals 0 if the denominator degree is greater than the numerator degree. Your second situation is you won't have a horizontal asymptote at all. That's if the numerator degree is bigger than the denominator degree. And the last of the situations for a horizontal asymptote are y equals a over b if the degrees are equal. A and b are the coefficients of the largest exponent. Okay? So these are 3 things that you need to look for when you are graphing rational expressions. Holes, vertical asymptotes, they go up and down, and horizontal asymptotes, they go straight across. Okay? A couple of things that will also help you factor, of course. Holes are curved when factors have been crossed out. Any number that makes the numerator 0 is an x-intercept. This is a good one. Knowing an x-intercept can help us in the graphing process. We figure that out when we set the numerator equal to 0. This is after you've canceled. Does everybody understand? Now, the fourth one are your vertical asymptotes. Any number that makes the denominator equal 0. And lastly, in behavior, also models the horizontal asymptote. So they may ask you, as x is getting big, what's happening to the curve? Am I approaching infinity? Am I approaching 0? Am I approaching some arbitrary number? The horizontal asymptote is going to tell you what number is approaching. So you find that first, you find out you're in behavior. Lots of information. But it's all right there at the very top of your paper. Are there any questions before we get to an example? What's the first thing that we're going to have to do with any rational expression? Factor. Okay? So in number 1, we need to factor the top and the bottom. How does the top factor out? X minus 3 and x minus 2. So I'm looking for 2 numbers that multiply to give me 6, add to give me negative 5. What about the bottom? That's difference of perfect squares. X plus 3, x minus 3. So that's the first thing. We need to factor. Now, are there any holes? Yes. Because I can cancel out my x minus 3. That means there's a hole where that factor of x minus 3 equals 0. This is how you find the holes. So whatever factor you cancel out, you set that equal to 0 and solve. What does x equal? 3. So there's a hole that occurs at 3, comma, some number. All right? Now how do you find the y coordinate of that hole? You plug it in, not to the original, but to whatever's left over. Okay? So x minus 2 over x plus 3. That's what was left over after I canceled, right? I'm going to plug in 3 in for x. So when I do that, what's 3 minus 2? 1. And then 3 plus 3 is 6. So I have a hole that occurs at 3, 1, 6. So when I go to graph this on my graph, 3, 1, 6 is somewhere right in here. There's a hole there. You might be able to draw a better hole because my pen is as thick as it can be. But there should be a hole there. And I should be able to see the hole. Okay? Now your x-intercepts. That was the thing that I had you guys star, or that I starred, so you guys might have started. You find an x-intercept when you do what? Say again. Any number that makes the numerator equal to 0. So x minus 2 equals 0. So there's an x-intercept at what number? 2. So there's an x-intercept at 2, 0. Because an x-intercept is the actual point. So when you have an x-intercept, that means y is automatically 0. So it's always going to be a number 0. That's a good question. Did everybody understand that? Yes. Oh, no, the bottom will tell us our vertical asymptotes. Only the top will tell us our x-intercepts. That's a good question. So make sure we graph our x-intercepts. It's there. Now our vertical asymptote is when we set the bottom equal to 0. So x plus 3 equal to 0. The bottom equal to 0. So where is there an x, not an x-intercept, a vertical asymptote? And negative 3. X equals negative 3. Vertical asymptote, straight up and down. It's a dotted line. So we're going to draw a dotted line at negative 3. So that means that when I draw my curve, it's either going to cross nor touch that line. Okay? 2 more things. My horizontal asymptote. Now remember, your horizontal asymptote, that's one of 3 situations. You have to look at the degree of your numerator and your denominator. Degree. That is an exponent. It is a square at the top and a square at the bottom, which means the numerator and the denominator degree is equal. When it's equal, your horizontal asymptote is y equals a over b. And a and b are the coefficients of the largest exponent. So what's the coefficient of this right here? It's a 1. What's the coefficient here? 1. So my horizontal asymptote occurs at 1 over 1, which is just 1. Say it was like 6x squared over x squared. So then it would be 6 over 1, which would just be 6. But whatever the leading coefficients are, it's the top over the bottom. So horizontal, left and right, at 1. Median behavior, again, is based off of your horizontal asymptote, okay? Horizontal asymptote was 1, which means that as x approaches infinity, meaning the bigger x gets, the closer it's going to get to your horizontal asymptote, which is what? 1. And as x approaches negative infinity, y is going to approach 1. So whatever your horizontal asymptote is, that is what's happening as x gets really, really big. It'll just be 1 for this first scenario and then 1 for the second scenario. So basically, I can plug in any number for x, a really, really big number, like 100 or 1,000. When I plug it in, I'm basically going to get a number that's really, really close to 1. Because that means that as I'm graph more and more points on this curve, I'm getting very, very close to 1. I'm not going to be at 1, I'm not going to cross 1, I'm not going to touch 1. But I'm getting very, very close. That's why it's an asymptote there. Mm-hmm. Yeah, it's just like when we were doing exponential functions. Same concept. Okay? So now the graphics. Very simple. I already have 2 points. I can already see where my curve should be because it has to cross through these points. It cannot touch my horizontal asymptote, nor can it touch my vertical asymptote. Okay? And I know as x is really, really big, I should be approaching 1. So I know it should look like this. And maybe something else that can help us. I found my x-intercept. Maybe finding my y-intercept might help me as well. Your y-intercept. Very simple. All you do is you plug in 0 for x. Okay? And you can either plug it into the original or the simplified form to get the same answer. So if I plug it in, 0 minus 2 equals 2. 0 plus 3 is. So my y-intercept is 0, negative 2/3. The reason why x is 0 is because whenever there's a y-intercept, that means x equals 0. Okay? Lots of information. So that means it's crossing here. So all you do is just connect the points. There's the first part. Now with rational expressions, there are 2 curves that exist. Because a rational function is a part of the reciprocal family, wherever there's one curve, there's another one. And it's in basically the opposite area as one of the curves. So if I have a curve here, the other curve exists in this top left corner. If I had a curve up here, its other curve would be in the bottom left corner. Now, if you don't believe me, what's always a surefire way that you can graph an equation? Or, if you don't have a calculator, what's another way you can graph any function? It doesn't matter what kind it is. What do we do with exponential functions? How do we graph quadratics or exponentials or radical functions or any other type of function? Nobody remembers how we graph an exponential function? An x and y chart, okay? So if you do not believe me that every time you have a rational expression, when the curve is in the bottom right, there will be another corresponding one in the left, top left, then you can always do a table. But I'm telling you, every single time, it's always going to be opposite areas, okay? So the other curve is going to exist up here. If you want to be detailed in your graphing, then you pick a point, so then that way you know exactly what it goes through, okay? Questions?
Can we just do that, or do we have to?
No, I mean, these are going to be what I'm looking for, that x-intercept, that hole, and so if you can get this curve, then hopefully you will recognize that it's always opposite of that, okay? We need to factor. Can we factor the top or the bottom? No. So basically, it's in its simplest form, okay?
No.
Am I canceling anything out? So are there any holes? No. There are no holes here because I don't cancel anything out. I can find my x-intercept by doing what?
Plugging in
It's the top one
equals 0.
equal to 0. So 3x minus 7 equals 0. Let's solve this out. Add 7, divide by 3. 3 positive. So I have an x-intercept is 7 over 3, comma, 0. How do I find my vertical asymptote? set the bottom equal to 0. So x equals a positive 2. Horizontal asymptote, I look at what? It's going to be 3 over 1. Make sure you look at the degree first. What's the degree of the top? 1. Degree of the bottom? So since they're equal, you look at the coefficients. So it's going to be y equals 3 over 1, which is just 3. And lastly, the easy part.
Excuse me, teachers, if the following students are in class, they need,
Maybe not. Okay, so what's the end behavior? As x approaches infinity, y is going to approach.
these students need to report to room 2.
So what's the last end behavior? 3. And our y-intercept is found by plugging in 0 for x. So I have negative 7 over negative 2, which is just 7 over 2. 7 over 2 is about 3.5, which is right here. All right? Now, again, your curve, it has to go through your x-intercept and approach your horizontal and vertical asymptotes. And since it's in this bottom right, the other curve would have been in the top left. And if you look, that's where the y-intercept was, top left. Approach the vertical asymptote, approach the horizontal asymptote. Yes?
Okay, so the reason why we find the y-intercept is to know how high we have to go?
Yeah, it's kind of like another one of those critical type of points, just to make sure we're curving, especially in a situation like this. Our x-intercept was over here, and so we need to be sure where we would actually cross the y-axis, and it just confirms that it's going to be opposite areas. Yes.
Are your end behaviors always going to be the same number?
Yes.
And is it always going to be?
Yes.
If you got an answer that was like 3 over 2,
Then it'll be 3 over 2.
so okay,
So 1.5.
you wouldn't split it up. It would just be 3 over 2.
Exactly. Okay? So let's look at the next one. All right, so we factored, we simplified, we crossed out the x plus 3, which means there was a hole where? And negative 1/5. You find that y coordinate of that hole by plugging in the negative 3 back into our problem, our simplified form. So 1 over negative 3 minus 2, that's a negative 5. X-intercept is when we set the numerator equal to 0. But we have 1 equals 0, which is nothing. So we have no x-intercepts. Do I have a vertical asymptote? Where?
2 at 2.
At x equals 2. And then we just talked about a horizontal asymptote. Since the degree of the denominator is bigger than the degree of the numerator, it is y equals 0. So that means for my end behavior, as x approaches infinity, y approaches 0. And as x approaches negative infinity, y approaches 0. So let's graph all this information. Oh, you're right, I do need that y-intercept. I gotta plug in 0 for x, and when I do that, I get what for my y? Negative 1/2. Okay, so remember you plug 0 back in for x. Now again, the y-intercept is just another point to kind of help you graph this, okay? So, hole, negative 3, negative 1/5, which is about here. I have no x-intercepts. I have a vertical at 2. I have a horizontal at 0. Remember, if my horizontal asymptote is my x-axis, there's no way I can have an x-intercept. Okay? And my y-intercept is 0, negative 1/2. So as I approach negative infinity, I approach 0. Gotta go through that point. I can't cross my vertical asymptote. Where's the other curve? Top right. And it follows the same thing. You can't touch the vertical or the horizontal asymptote.
So when it says as x gets closer to negative, like when you have 0 over 0, 0 is technically the asymptote.
Uh-huh.
Like because you get it closer to 2 on the other side, not vertical.
Oh, no. Well, that's because I'm approaching 2 here. if I'm getting closer to the vertical asymptote, I'm approaching 2. Not infinity. As I'm approaching infinity, that means I'm going in this direction. So if I was going the other way, I wouldn't be approaching infinity, I'd be approaching 2. That's why it shoots up.
Yeah, it just said it was the approach to 0.
Right. Got the next one. Got all that information. I'll give you about a 2. So this was a nice one. Nice whole numbers. Easy to graph. Okay? Now the last one is a little different. Okay? Not all rational functions look like this, but you needed to see another situation, or you need to see all types of situations. The reason why it's different is because let's factor number 5. Okay, let's factor number 5. Everybody got Forrest information now? Number 5, the top factors out as x plus 4, x minus 4, those are difference of perfect squares. And then there is a what in the denominator? A greatest common factor of a, just the 2. So when I factor out the 2, I'm left with x squared plus x minus 6. What two numbers multiply give me negative 6, add give me a positive 1? What is it? 3 and negative 2. Now the reason why this is a little bit different is because I have a 2 and I can't cancel anything out. Okay? So I have no holes because nothing cancels out. Okay? And unlike the other ones where I only have one x-intercept, how many am I going to have here? 2. Because it's when you set your numerator equals 0. That means I have to set both factors, x plus 4 and x minus 4 equals 0. So I have 2 x-intercepts, not 1 like the last time, okay? So I have an x-intercept where? So 4 is 0 and negative 4 is 0, because I basically solve for x. And unlike the other ones, I don't have one vertical asymptote, I have just 2. I have to set the denominator equal to 0. So x plus 3 equals 0, x minus 2 equals 0. I don't include the 2 because there's no x associated with it. So it's just like an arbitrary number. So I have vertical asymptotes at negative 3 and 2. My horizontal asymptote is a over b because my degrees are equal, so 1 over 2, which is 1/2. Because the leading coefficient is 1 up here, and then 2 at the bottom, so 1/2.
It's because they're both x squared, right?
Exactly. So I have basically, it approaches 1/2. So remember, you can find out end behavior without even having to graph any of this, okay? Remember, all you gotta do is figure out what your horizontal asymptote is, then you have your end behavior, okay? Thank you. It's like, it's not written down like I got both of you. So y-intercept, I gotta plug in 0 for x. Since I didn't cancel anything out, I have to look at my original. So that's basically gonna be negative 16 over negative 12, because when I plug in 0 for x, this part goes away, and those parts go away. Negative 16 over negative 12, what is that? 4 over 3. So I have all this information. Negative 4, 0, 4, 0. Those up, cut me off. I see it coming. 3, plus 2. And you know what? We'll finish this up tomorrow because I don't